Hi everyone, so today we're going to be solving systems of equations by graphing. So if you actually have a piece of graph paper, that would be great. If not, then we can just use a lined piece of paper. So let's go ahead and title our paper Systems of Equations. Let's actually say Solving Systems of Equations by Graphing. Okay, so for our solving systems of equations by graphing, we need to make sure we know what a system actually is. So this means that we have two or more equations with the same variables. And then our other way that we know that we have a solution to our systems. So this is when we know we have systems, if we have two or more equations with the same variables. And then in order to know that we actually have solutions, this will be an ordered pair. And an ordered pair is like a point that make all of the equations in the system true. And this is typically where the points intersect. Okay, so in order to know that we have a system, that we're actually going to use it, we have to have two or more equations with the same variables. And then when we know that we've actually solved, we got a solution, it's going to be an ordered pair, and it's where the points actually intersect the graphs, the lines. You'll see when we're talking about it. Okay, so we're going to go over there's three different ways. You guys have probably learned these. So three ways to solve systems of equations. We're going to do graphing right now, and then we have substitution and elimination. So this should be a review, but I know that we always have trouble with it, so I'm going to make sure we are getting this again. So let's go ahead and start off with our first example, number 1. And we are going to have our equations y equals 2x minus 5, and then we also have our x plus 3y equals 27. Okay, so first we're going to rewrite each equation into slope-intercept form, and remember that we have a slope-intercept form which looks like this. Our y equals mx plus b. This is just a lot easier to graph when we're in our y equals mx plus b form. So we have this one on our equation that already is y equals mx minus b. That's okay. And then now we have to figure out, we have to try and get y by itself over here. So I'm going to do some side work with this equation. I'm going to go ahead and write it over here. And I'm going to subtract x from both sides, leaving me with 3y equals negative x plus 27. The reason why I'm putting the x there is in the front of the 27 is because the x comes before the b value. Now I'm going to go ahead and divide each of these by 3. And yes, I am just dividing both sides by 3, but this is two terms, so it's two different fractions. These divide out, I get y equals, you can leave this as a negative 1/3 x, which helps us see what our slope is. And then 27 divided by 3 is 9. So go ahead and simplify that. So these are the equations I'm going to be using to actually graph my systems of equations now. Okay, so on your piece of graph paper, let's just do a graph where we do a 10 by 10. Mine is a little bit off, but that's okay. So if you guys refresh your memory, we always start with the b, the y-intercept to graph. So let's actually make sure we have that steps right there, just so we can embed those in our notes. So if we have step number 1, you're going to plot b, or that's the y-intercept. And remember, our y-intercept, sorry, that says intercept, I-N-T-E-R-C-E-P-T. You're always going to plot your y-intercept first. So let's go to this equation, and our y-intercept is a negative b. If it's a y-intercept, it's crossing our y-axis. at -5. So we're going to go 1, 2, 3, 4, 5. That's my first point. And then our second step now is to use your slope to plot next point. Okay, so now we're going to use our slope. If this is not a fraction, it's just 2 over 1. We just put a 1 underneath it. So that means you do rise over run. So don't forget that. And then if it's not a fraction, you put it over 1. So rise over run, we have 2 over 1. So from your y-intercept, you're going to go up 1, 2, and then to the right 1. You can continue doing that process. The more actually dots that you have when we are graphing, the more accurate this is. So I'm going to go ahead and connect my dots now. Be sure that you draw arrows on it because this line is continuous. It's going to keep on going. So now I'm going to go ahead and draw my other equation. So start your y-intercept, which is positive 9 this time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm actually going to be up here. I didn't do my graph. I did 5 by 5 instead of 10. And then I'm going to use my slope from that point. So down 1 to the right 3. So down 1 to the right 3. We're kind of a mess over here. Down 1 to the right 3. And then down 1 to the right 3. So it looks like if I were to use this slope right here and go up 1, 2 over 1, that's actually my point of intersection. So I'm going to extend my line, and I'm also going to draw my line. Hopefully you guys drew a line that's better than mine, or a graph. So this is actually the point of intersection here. And so our actual solution to our equation here, so solution, actually we just have one solution, so our solution to our system is going to be, let's count our points, so 1, 2, 3, 4, 5, 6, so as our x, remember your x comes first, so 6, comma, this is your x, now we're going to go up, so 1, 2, 3, 4, oh sorry, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So 6, comma 7. This is our actual solution. This means that we have one solution. Okay, so one solution is 6, comma 7. Okay, let's go to our next example. So for our example here, number 2, our equation is y equals 1/2 x minus 5. And our other equation that we actually are going to have to solve and put into y equals mx plus b form is 2y minus x equals 4. So let's go ahead and get this in y equals mx plus b form by adding x to both sides. And now I get x plus 4. Now we're going to divide by 2. And now I get y equals, again, make this a fraction, 1/2. It makes it easier to define rise over run. Plus 2. 4 divided by 2 is 2. Okay, so I'm going to go ahead and get my graph ready. And again, I did another 5 by 5. This one would have been better to do a 10 by 10. So now I'm going to start off with my y-intercept, the one that's already in y equals mx plus b form. So I have a -5, 1, 2, 3, 4, 5. Now I'm going to use my slope of 1/2, rise over run. So rise up 1 over 2, up 1 over 2, and you just keep going from that point. I'm going to go ahead and now connect those dots, make sure I have arrows at the end of those lines, and extend it further because it's a continuous line. And then I'm going to go ahead and graph my next one. This is a +2 at the y-intercept, and then this means I have up 1 over 2, up 1 over 2, and I can even go the opposite way. If I run out of room, I can go down 1 to the left. So you have to go negative, negative, because a negative divided by a negative is a positive. So we go ahead and connect our dots there as well. And we see that we actually have parallel lines here. So that means that we actually, because this will never touch, so we have no solution. Because they are never going to touch because they are parallel lines. So I'm going to have you guys just write, this is our solution, or our statement, no solution. I'm just going to write y. We have our parallel lines that are not going to ever intersect. Parallel lines do not intersect. Therefore, we do not have a solution. Okay, now let's go on to our third example. And our equations for this one is y plus 7 equals a negative 3 times x minus 1. So these equations get a little bit more difficult. And then it looks like we have to do 3x plus y equals negative 4. So we need to put both of these equations into y equals mx plus b form. So let's go ahead, and our first thing on this equation is we are going to distribute. So negative 3 times x is a negative 3x, and then negative 3 times negative 1 is a positive 3. Then we have our y plus 7 that we don't have to distribute anything to, so that gets to stay there. Now I'm just going to make sure, so I already have my x over here, I have my y-intercept, but I have a 7 over here that I need to get in order to get y by itself. So now I'm going to go ahead and have y equals a negative 3x. 3 minus 7 is actually negative 4. So this is my final equation I'm going to use to graph. And then this one, I just need to subtract 3x from both sides, leaving my y by itself, getting me y equals negative 3x minus 4. Okay, oh, look, if you actually see this, we actually have the same line. So this automatically means that we are going to have infinite solutions. So that is going to be my answer, but I'm going to show you graphically what that means. But infinite solutions mean we have the same slope and y-intercept. Okay, so that's just some key tips here. So now let's go ahead and graph. Okay, so again, we're going to start off with our negative 4, our y-intercept. So 1, 2, 3, 4. And we're going to use our slope. Remember, if this is not a fraction, you're going to put it over 1. So I have a negative 3 over 1 as my slope. So we're going to go down 3 and then over to the right 1. I don't have any more room on my graph, so I'm actually going to reverse that. And I'm going to go up 3, but then to the left 1. So I'm going to go 1, 2, 3 over 1. 1, 2, 3 over 1. As long as you're going negative in one direction, so left is negative and down is also negative on the graph, and then to the right and up is positive. So now I'm going to go ahead and connect my dots, and we would see that if I were to graph this same one, I would still get the same thing. So I'd have my negative 4, and then I would go up 1, 2, 3 over 1, up 1, 2, 3 over 1, and I end up getting the same exact line. So that's why this is infinite solutions, because all of these points lie on the same line. So that's our infinite solutions. So just to recap, you guys, on what makes all of our different solutions. So I showed you an example of infinite solutions. This is our same slope and y-intercept in our equations. That's how you will tell. It's also the same line. So let's actually say that. Same line on a graph. And then to recap on example number 2, if we have no solutions, that means that we're going to have parallel lines. And if you guys actually look at this, our slopes are the same. So slopes are same, but y-intercepts are different. And then up here for our one solution, we actually have a point that crosses at that value. And here we see that our slopes are different as well as our y-intercept. So let's just make a little note of that. So slopes and y-intercepts are different. Okay, so that's our notes for today. Make sure that you guys have those all down. That's a lot of information. And I will see you guys in class. Thanks.